information that could support us in these particular use cases. Now, we're also looking at the information throughout the product and material life cycle, right? So, take a door, for example, right? We've seen doors before, and we've touched them, we've opened and closed them. We see doors around ourselves. Now, if you think about it as a use case, we're talking about the product. It's a manufactured product that you can take out of the building and place it somewhere else, maybe for a different purpose or for the same purpose. If you talk about recycling, you're talking about materials, right? So the door becomes a material, whether it's timber, whether it's an aluminum door, whether you have seals, whether you have doorknobs, hinges, etc. Those are different components which are made out of different materials. And if we want to recycle them, we're talking about materials, not products. And this is important. Why is it important? Because, well, when we talk about different aspects, we're talking about very different information. So if we want to reuse something, we certainly need to understand manufacturer's information. What are the design requirements, right? What is the construction information that should be attached to the object? And finally, at the pre-demolition audits, what test information do we need? Do we need a lab test? Do we need to recertify the door that it's compliant for fire rating or acoustic rating? Does the manufacturer have take-back scheme? Do we have design information for architectural appearance of it? What material it is made of, etc. If we talk about the materials, if we want to recycle something, we talk about a very different set of information. We're talking about chemical, physical, mechanical composition. We're talking about information about the actual material. And this is very different from what we gather as construction professionals, right? When we talk about doors, we're talking about, okay, here's a product, deal with the product. But now we're in the realm of materials as well. If we're at the pre-demolition stage, we probably want to send the material to the lab test to actually understand, what this material could be used as in the future. So, for instance, if you take concrete, obviously we don't have doors out of concrete, but if you take concrete, you're now talking about comprehensive strength, and you're talking about how it could be crushed. It becomes an aggregate, and it opens a can of worms, right? Because it's a lot of information that we need to understand. Obviously, as our project suggests, we try to automate things. Now, in order to automate things, we need to have the data sets that we can actually share between different applications. Okay, so first of all, we need information to be described in common terms. We need to agree on the common terms so we can interpret the same information in multiple applications, whether it's your design application or whether it's a document management system. And it needs to be searchable and reusable. Second of all, it needs to have some kind of structure, right? So it needs to the information should be relatable, right? So we have a door that sits within a wall. A wall sits within the building. Building sits within a site. A site is within the country, and the country is in this world, right? So we create the relationships between the data. This is structured information. That's what we want to kind of represent. And finally, we want it to be software compatible, right? No matter what software you use, it needs to be open so we can actually reuse it. In the end, our aim is to create, machine and human readable data sets. Now, if we take this notion of structured data, etc., we can borrow the certain aspects from semantic web, so web 3.0. We can create ontologies to create relationships between different classes, entities. So you can describe the relationships between things, right? So I'm here in this room. I'm related to the audience, right? So we have a relationship. We can establish that, and we can record it, right? So this is how semantic kind of web works. It would be great. It's quite advanced data structure, if like, but it doesn't necessarily translate into what we use in construction day to day. Unfortunately, we're a little bit backwards. But we have something different in place, which is called OpenVIM. So OpenBIM is kind of a term thrown around in the industry. And at the heart of this OpenBIM, we have IFC schema. So not really sure how many of you know IFC schema, but if you used 3D applications, the great projects, you spin around, click on the object, and it shows different information. Most likely it is IFC step physical file format that has been shared with you. You can obviously opt for proprietary systems, but we're doing the research so it could be open for everyone and everyone can reuse the data. Therefore, at the heart of our solutions, we're using IFC schema. Now, IFC schema is very structured. It is actually quite rigid, and it is already defined quite well. It has multiple entities like doors, and in the door example, it describes all sorts of property sets, whether it's whether we want to describe manufacturer's information or warranty information or service life, etc. We can attribute this information to the door, right? And it can be digital and it is represented the same way, no matter what application you use. This would be great, and we would use it, and we're using it. However, when we start talking about waste, construction and demolition waste, and especially when we talk about materials, we lack the definition in the IFC data schema. Therefore, we go for the next best thing, which is Building Smart Data Dictionaries. Now, this is another service provided by Building Smart International, where you can create your own dictionary. So this is part of our work. We're creating a data dictionary for waste management, right? And we want to describe what information you need to gather during design, construction, operational, and pre-demolition stages and beyond to describe products and materials. Okay. So just to give you like a little bit of an idea, so we have a door. Let's imagine you've designed the door, you've placed it in a building. It looks great in 3D. It has some information. You can then use Building Smart Data Dictionary service and create your dictionary to enrich your information model with your data. In our case, we're talking about waste management. So we've done already some testing where we can, define different classes. We can define properties in great detail. So let's take, for example, concrete. We suddenly can create different property sets, right? For concrete recycling, we need leaching properties and minimum aggregate size and so on and so forth, right? We're creating this dictionary in describing the actual parameters, not the values, but the parameters themselves. We can go even deeper and say, okay, we actually have waste code property, right? Waste codes are described in the European waste classification codes, and we can actually describe this information, right? So we can define the data type, it's a string, or for different data types, it could be integer, etc. And we can create lists of available values, right? So in this case, for waste code, European waste classification codes are used. This information can then be used by any software that connects through the APIs to the data dictionary. It creates the consistency between software applications when we exchange the information, right? So if I'm a designer and I want to speak to a client, or if I want to speak to a pre-demolition auditor, I can describe things in the same way. And not only I can describe things, but the software we use can actually reference the same information. So what we're trying to do is once we have all this data in place, which hopefully we'll have by the end of August, which is going to be available for everyone to use. We want to use the systems that we use currently based on it and use our information for information exchange based on IFC schema, enriched by the data dictionaries which are connected through the BSD service. Once we have that information in a structured manner, we can then do things quite differently. We can then use Another service, again, another standard by Building Smart International called Information Delivery Specification to write the actual requirements that are machine and human readable. And we can verify whether information is present at any given stage during the construction, during the product or material life cycle. I know this is a lot to take in for many of you, but if you're interested in this research, you can follow us on LinkedIn. We regularly publish our articles about this journey on BIM+, and obviously you can find us on Recon as well. Thank you very much.